Everybody hears real-life Iron Man suit and imagines one possible machine. A man flying through the sky, shrugging off bullets, seeing through walls, talking to an AI, and dominating the battlefield alone. But the real story is actually much more interesting than that. Because the reason we do not have a real Iron Man suit yet is not that the idea is stupid. It is that the idea is too ambitious. It is trying to combine a fighter jet, a bulletproof vest, a robot, a supercomputer, a life support system, and a human body into one moving machine. And that is exactly why it might change warfare forever, if anyone ever gets it right. So here's what a real-life Iron Man suit actually is in engineering terms. It is not just an armor, it is a powerful human combat platform. That means a machine wrapped around a person that boosts strength, improves awareness, protects the body, helps movement, and maybe even controls other machines nearby. In the movies, Tony Stark solves this with fantasy-level power, materials, and software. In real life, engineers have to solve it with actual batteries, real metals, real heat, real fuel, real sensors, and a real human body that gets tired, overheats, panics, and then breaks. And that is where things get real fascinating. Because parts of the Iron Man suit already exist, believe it or not, we already have powered exoskeletons that help people carry more weight. We already have jet suits that let people fly for short bursts. We already have advanced body armor made from ceramic and composite materials. We already have augmented reality helmets, thermal imaging, night vision, and AI systems that can process information faster than humans. We even have an autonomous fighter jet testing and drone teamwork concepts that look like the first step towards a battlefield version of Jarvis. So the real question is not, can one single company build a movie suit tomorrow? The real question is this: how close are we to building something that does the same job in a realistic way? The first part is movement. A real Iron Man suit has to make a human stronger without making them clumsy. That sounds simple until you think about how complex the human body actually is. Your hips, knees, ankles, shoulders, elbows, and spine are constantly making tiny changes every single second. If a powered suit pushes at the wrong time, even slightly, it does not feel like help, it feels like resistance. That is why real exoskeletons today are still limited. Some can help the legs during climbing or load carrying. Some can reduce the fatigue. Some can help industrial workers lift heavy objects. But none of them turn a soldier into a superhero. They are support systems, not magic. Then comes the protection, the most important part. This is where most people picture a full metal shell, but in real life, full body heavy armor creates a massive problem. The more protection you add, the more weight you carry. The more weight you carry, the more energy you need. The more energy you need, the bigger your power system becomes. Then that bigger power system adds even more weight. This is the trap that kills most sci-fi suit ideas. Modern armor is amazing at protecting the torso, especially with ceramic plates and advanced composites. But full body rifle rated protection is much harder because the human body bends, the knees bend, the shoulders rotate, the neck turns. A rigid shell that protects everything also fights your own movement. So a realistic Iron Man suit would not look like a smooth Hollywood shell. It would probably be modular with heavy protection only over the most important zones and lighter flexible protection everywhere else. Then there is flight, which is the most iconic part of the fantasy and the hardest part to scale. Yes, jet suits are real. Yep, people have flown with turbines strapped to their arms and back. And yes, it looks like Iron Man for a few seconds, but the limitations are brutal. Short endurance, extreme noise, huge heat signature, limited range, hard control, high risk. These systems work because liquid metal carries a lot of energy, but even then, you're talking about minutes, not hours. Once you add heavy armor, extra sensors, cooling systems, communications gear, maybe weapons, maybe counter-drone systems, and the whole thing starts becoming too heavy and too inefficient. So, if you are imagining thousands of flying armored soldiers crossing battlefield like Marvel characters, this is very unlikely anytime soon. And now we get to the biggest reason the suit does not exist yet. Power. Power is the hidden villain of the entire story. A real combat suit needs powerful movement, sensors, onboard computing, communications, cooling, and maybe active stabilization. And that is a huge energy demand. Batteries today are good, but not good enough for this dream. Fuel has far more energy packed into it than batteries, which is why jet suits use fuel. But fuel creates its own problems: heat, fire risk, noise, exhaust, and logistics. This is why the real Iron Man challenge is not just materials or AI, it is energy density. The movie version cheats with the arc reactor. Real engineers do not have that luxury. Now, even if you somehow solve movement, armor, flight, and power, you still have the human problem. A soldier inside the suit must be able to think clearly. That means the helmet display cannot make them dizzy. The sensors cannot overload them with information. The controls cannot be confusing. The machine cannot trap heat and cook the person inside like a chicken. The suit cannot be so complicated that the operator spends more time managing the suit than fighting the enemy. This is why the real engineering of an Iron Man suit is not about one breakthrough. It is about integration. It's about making every subsystem work together without turning the human into the weakest link. That is also why the scariest version of the real Iron Man suit may not be the flying version, it may be the thinking version. Because the part of Iron Man that is arriving fastest is not the rocket boot, it is the battlefield brain. AI can already assist with object detection, route planning, sensor fusion, threat spotting, communication support, and unmanned teaming. This is where your Queen Bee idea becomes powerful. A realistic future suit may not send one man flying like a superhero. Instead, it may turn one operator into the command center of a small machine army. The human inside becomes the decision maker. Around them, drones scout ahead, map buildings, watch rooftops, relay communications, jam threats, track targets, and maybe strike when ordered. In that world, the Iron Man suit is less like a metal costume and more like a wearable war network. That is what makes it fearsome. Not invincibility, not flashy weapons, not even flight. It becomes fearsome because it compresses the time between seeing and acting. A normal soldier sees, thinks, decides, and then moves. A suit enhanced by AI, sensors, and unmanned teammates sees more, understands more, and reacts even faster. It can carry more gear without exhausting the user. It can move longer. It can survive better. It can coordinate more machines. It can dominate information before it dominates firepower. That is also how it could change warfare forever. Modern war is becoming more transparent, more drone heavy, and more data driven. The battlefield is full of sensors now. Cheap drones can find you, loitering munitions can hunt you, electronic warfare can confuse you. In that kind of war, the future winner may not be the soldier with the thickest armor. It may be the soldier who is best connected, best informed, least fatigued, and most able to command nearby autonomous systems. In other words, the first real Iron Man suit may not look like Iron Man at all, but it may do something even more dangerous. It may turn one human into a mobile battlefield node. So what would a realistic near-future Iron Man suit actually have? It likely have powered leg assistance for running, climbing, and load carrying. It'd have modular ceramic composite armor over key body zones. It would have an advanced helmet with augmented reality, thermal vision, navigation overlays, and team tracking. It'd have an onboard AI for filtering information, so the user only sees what matters. It would have secure communications and jam-resistant local computing. It would probably carry short burst battery power for assist functions. not unlimited power for superhero movement. And most importantly, it would be built to control drones and robotic helpers around it. So with all that being said, the truth finally boils down to this. The real-life Iron Man suit is not impossible, it's not a dream. It is just not arriving in the clean Hollywood form people expect. The insane engineering is not about building one magic suit. It's about merging robotics, material science, power systems, AI, body armor, human physiology, and autonomous warfare into one single system that a real person can survive inside. That is why it's taken so long, and that is why, if someone finally gets the formula right, you will not just create a cool gadget, you'll create a new kind of soldier. And that is the real answer to the title. The Iron Man suit might change warfare forever, not because it makes a man fly like a comic book hero, but because it could make one human fight with strength of a machine, the awareness of a sensor network, and the reach of a drone swarm. That is when the suit stops becoming a fantasy and starts becoming doctrine.